Cheers to the wish you were here, but you're not, 'cause the drinks bring back all the memories of everything we've been through. Toast to the ones here today.
Hello
Toast to
everyone,
the ones
today
that
we
we
are going
lost
to
on the way.
tackle one board exam problem, no, which is related to the subject differential equation. And prior to proceeding, to this problem, please do not forget, to subscribe to my YouTube channel. Okay, so proceeding, we have here an equation actually, in which it is given by 1 plus y squared dx plus 1 plus x squared dy is equal to 0. And we are going to solve this equation with the initial condition. When x is equal to 0, your y is just simply equal now to -1. Okay, so first, we need to solve this problem, getting first the derivative of your y with respect to x. Okay, so from the given, we have here 1 plus your y squared quantity, and then we have here dx plus your another term 1 plus x squared, and this is dy is equal now to 1. Okay, so after this one, we need to multiply this whole equation with, since we already have this dy and this dx, so we will go into the dy over dx form. So we have to multiply this one with 1 over dx. Okay, so distributing this one to each term, from the left side and also from the right side. So we have here 1 over dx times this 1 plus y squared dx. So here dx will be cancelled out, so what remains is this 1 plus y squared. Okay, and then the second term is we have here 1 plus x squared, and then we have here dy over your dx, which is 1 over dx times 0 is simply just equal to 0. So we will have this dy over dx form, which is just equal to, we are going to transpose this one to the right side, so this would be minus, so minus. Okay, so we have here transposing this one, so we have 1 1 plus your y squared, this quantity transpose to the other side, minus of this 1 plus y squared, and then over over this 1 plus x squared. Okay, 1 plus x squared, so that we could arrive to this form of dy over dx. Okay, so why I'm doing this, because we need to check if we can solve this one by variable separable, by homogeneous equation, by exact differential equation, and so on and so forth. But basically, I advise you to start solving the given equation using the variable separable. So if you can solve and comply when the equation given will comply to the standard format or standard form of this variable separable equation, so you will solve it using the variable separable. So that is why I am checking this given equation if this can be solved using variable separable. So from this, as you can see, your dy over dx is just a function of your we have here 1 plus y squared, and we have here 1 plus x squared. But if you can still remember the form of the standard form rather of the separable equation, this will comply with your dx dy over dx rather equal to the j as a function of your x times the p as a function of your y. Okay, so from the given, we can say that from here we can say that your j as a function of your x is just simply your, this would be equal to 1. Okay, this 1 over 1 plus x squared. Okay, this one, no? So we have a function of x, no, with this 1 over 1 plus x squared. And do you have a function of this p as a function of your y? So based on this one, you can still have, no, this p as a function of your y, which is the negative, no, of this quantity 1 plus y squared. Okay, so therefore we can say that the given, no, equation is or can be solved, no, using the variable separable, since this comply, no, with this form of dy over dx equals now to j as a function of your x times the p as a function of your y. Okay, so from here you may opt also that your j as a function of your x, no, you may opt that this negative sign will be put here, so you can opt also to use negative 1 over 1 plus x squared, and your py will simply just equal now to this only 1 plus y squared, no, but you can still opt to use this one, no, your gx as this value and your py as this negative of your 1 plus y squared. Okay, so you can, this is interchangeable, no, if you wish, no. And then proceeding with this one, so we have now this form, no, from dy over dx equal now to this negative of your 1 plus y squared, and this is quantity, no, and then we have here 1 plus x squared. So we will combine, no, those having the same variables, no. So in this case, in terms of your dy, we have here dy over your, so we have 1 plus y squared. Okay, 1 plus y squared. You may use, no, the negative, no, in this term here, but in this lecture we'll just consider, no, this 1 plus y squared, and this negative sign will be carried by this 1 plus x squared. Okay, so dy over this 1 plus y squared equal now to, so we have here negative, no, dx, no, over this 1 plus x squared. Okay, and then after this one we are going to integrate, no, and then integrating this one, so we may go directly, no, with the integral sign. Okay, so extracting the negative 1, no, negative sign outside the integral, so we will have this one. And then actually before solving this one, no, you cannot solve directly this given integral, no, without using some properties, no, from the integral calculus, no, if you can still remember. We have some properties there in which the integral of your du over the sum of your a squared plus u squared is just simply equal now to 1 over a arctangent of your u over a, no. I hope you can still remember that property from the integral calculus. Okay, so we may have, no, this form here as our reference here. So we have this du over your a squared plus your u squared, no, is equal now to 1 over a, and then we have here the arctangent, no, arctangent of your u over your a. So this is now a property of from our integral calculus. Okay, So actually we can use it here, no, from this term here, in which our a is just simply 1 and our u here is our y. But for the term here, so our a is still 1 but your u is the variable x, no. Okay, so from this we will consider, no, this left side of this one, considering the integral of dy over this 1 plus y squared. Okay, so therefore we can say based on this one, this is 1, no, 1 over a. So your a is 1, so this is 1 over 1, and then this is arctangent, no, arctangent of your u. Your u here is your y. Okay, so u over a, so this is y over 1. Okay, so plus, no, plus a constant, so we will assign c1 here. Okay, so this is not for the this side, this integral, and for the integral of this dx over 1 plus x squared, so we will have this negative. Now we will extract the negative, no, so we have this 1, again 1 over 1 arc tangent of your u. Your u here is your x, no, x over 1. Okay, plus your constant is we will assign as c2. Okay, so we can say that this is just equivalent to arctangent of your y plus c1 equal now to the negative of arctangent of your, this is our variable x. Okay, x plus your c2. So we will enclose this one with a bracket. Okay, so further, this is just equivalent to arctangent y plus c1 equal now to, we distribute the negative sign, so negative arctangent of your x minus your c2. Okay, so after that one, we will transpose this c1, no, to the right side, so this will be equal then now to arctangent y is equal now to negative arctangent x minus c2 minus c1. Okay, so proceeding, so we will assign here, no, to let us make this one into a single constant, no, so we will assign, no, let c3. Okay, so we are going to let, no, c3 is equal now to this negative c2 minus c1. Okay, c3 is just equal now to negative c2 minus your c1, so the equation will then be equal to this arctangent of your variable y equal now to, okay, so we have here negative arctangent of your x, and then we have here plus your c3. Okay, or we have this form here, no, we have this form arctangent of your y, then transposing this one, plus arctangent of your x is just simply equal now to c3. Okay, so from here, based on the initial condition, so using this x equal to 0 and your y equal to negative 1, okay, so if your x is equal to 0 and your y is equal to negative 1, so by substitution, so we have here this arctangent, no, of your y, which is equal now to negative 1. Okay, plus the arctangent, no, the arctangent of your x, no, which is 0, okay, is equal now to C3. So using your calculator, no, so we have this value of your arctangent of -1, which is -1/4 of your pi, okay, and then the arctangent of 0 is just simply equal now to 0, and this is just equal now to C3, okay. So we can say that our C3 is simply just equal now to this -1/4 of your pi, okay. So we have here C3 is equal now to -1/4 of your pi, okay. So by substituting this C3 here, no, so we can have this arctangent of your y plus the arctangent of your x is just equal now to -1/4 of your pi, okay. So again, no, solving this one, I think you need to consider also another property, no, of this tangent, no, tangent property specifically, in which you are going to consider, no, this property here, no. I think this is it, no, this property of your tangent of your a plus b, okay, which is equal to this term here, no, the sum of the two tangent, no, tangent a plus your tangent b, and then this is over this one minus the product of your tangent a and your tangent b. So you can check this one, no, this property, this tangent property, and I think this is it, no, we will use this property here, okay. So how will we use this property from our equation here? The arctangent y plus arctangent x is equal now to -1/4 pi. How we will apply this one, okay. So from this one, from this property, we need to assign, no, we need to assign no, let, so let us let, no, this a here, a is just simply equal to this arctangent of your x, no, and then our b is just the arctangent of your y, okay. So we will assign, no, with these variables a and b, so that we can solve this problem, okay. So therefore we can say that using this one, so arctangent a, so this would be a plus b, no, okay. This is our a plus b, and we will take, no, taking, so we will take, no, the tangent, taking the tangent, okay, taking the tangent on both sides, no, on both sides, okay. So we have here, so we already assign, no, a equal to this arctangent x, and then our b equal now to this arctangent y, okay. So from this we will have this from this actually we can use first the arctangent x, no, from arctangent y plus arctangent x equal now to -1/4 of your pi, okay. So using this one, assigning this a equals to this arctangent x, so we will have this form, no, so we have A, no? A plus your B equal now to negative 1/4 of your pi, okay? I think we will better understand, no, if we will have this form, no, in which we will assign A as the arctangent x and your B as the arctangent y. So therefore, their sum is A plus B equal now to this negative 1/4. Okay, so proceeding, no, with our calculation. Okay, so after that one, after taking this form, taking the tangent on both sides, so meaning from this one, so we have this tangent. Since we are taking the tangent on both sides, so we have tangent of your A plus B equal now to the tangent also of the other side, which is the tangent of your negative 1/4 times this pi. Okay, okay, so by this we can use now this property, no, we can actually use this property. Okay, so by using this one, so we will have this value here, no, replacing this tangent of A plus B here by this value here. So we can say that this is equal now to tangent of your A plus tangent of your B all over this 1, no, minus the product of tangent A and your tangent B, which is equal now to this tangent of your negative 1/4 of your pi. Okay, so after this one, we have the tangent, no, the tangent of your A, where your A is the arctangent, so we can substitute it here, no. The A is this one and your B is this one, no. So substituting, so we will have substituting your A, no, equal now to arctangent of your X and your B equal now to arctangent of your Y. Okay, so we have this new form here. Okay, tangent of your A, no, is the arctangent of your X. Okay, arctangent of your X, and then plus tangent of your B, which is the arctangent of your Y. Okay, all over this 1 minus, okay, 1 minus the tangent of your A again, which is the arctangent of your X. Okay, the tangent of A, and then we have here the tangent of your B, which is your arctangent of your Y. Okay, which is equal now to this, no, this tangent, no, this tangent of your negative 1/4 of your pi. Okay, proceeding. But take note, no, another property, no, for us to solve this problem, we need to remember, no, the tangent property also, that we have this form, no, tangent of your arctangent X is just simply equal now to X. Okay, this is another property, so you need to remember, no, some properties, no, so that you can solve the given equation. So another property is the tangent of your arctangent X is just simply equal now to X. So therefore we can use this from this equation, no, tangent of the arctangent X, so therefore tangent of the arctangent X is just X, no, and for the Y, this is also just equal now to your Y. Okay, so arctangent y is just equal now to y. So from this, we substitute this property, no? So this tangent arctangent x is just simply equal now to x, okay? Plus this is y, no? So this is y, okay? Over 1 minus this is x times your y, and this is just equal now to the tangent, no, of your negative 1/4 of your y, no? If you will use your calculator, it's just simply equal now to 1, okay? So simplifying this one, we will have this form, no? X plus y is equal now to this, we will close multiply, no? Negative 1 times your 1 minus xy, okay? And then distributing this one, so we will have this x plus y is equal now to negative 1 plus xy, okay? So negative times positive is negative, and negative, so plus xy, okay? So we have this form, no? X plus y is equal now to xy minus 1, okay? And we will going into this, we transpose this one, no, to the right side, to the left side rather. So we will have this x plus y, so this is minus xy, and then this is plus 1, okay, equal now to 0, okay? So this would be it, no, our answer, no, to this given equation. So we have x plus y minus xy plus 1 equal to 0, or you can use also this form, no, here, no, we can use also this one equal to your xy, no, minus x, no, minus, okay, so excuse me, so xy minus x, and then we have now this minus y, and then another one is minus 1 is equal to 0. You can also use this form, no, because if we are going to multiply this one with negative 1, so this negative xy will then be positive, no, xy, and this one will be negative, so negative x, negative y, and then this one is negative 1, no. So you can also use this form also, no, as your regarding this sample say board problem related to our subject differential equation. And thank you everyone for watching and listening, no, with this lecture video, and I hope again that you learned something out from this one. And that would be it for this day, and once again, thank you very much for watching, and God bless us all.